So what is a series? If you haven't learned about sequences, I would definitely suggest going back and watching those videos, because what a series is when we take the terms of a sequence and just add them together. So an important thing we're going to need to know is called sigma. This is a Greek letter and it represents sum. So we use this when we're writing out series. So let's go through a couple of examples of what that might look like. So just like with sequences, we could have a finite sequence or an infinite sequence. And for series, we can either have an infinite or finite series. So if I'm looking at this sequence up here, 5n minus 3, and let's say I wanted to add up the terms 2 through 5. So we want to add u2 through u5. The way I would write that then is I would turn this into a series. So I would write this sum. We would put when n equals 2, because that's the first term that we want. And then at the top we would put 5. And then I'd put in my equation. So this is our proper notation. What this means is, let's break this apart. Down here is going to be our first term of our series. Here will be our last term of the series. And then again, that summation symbol means we're going to add everything in between. So we're going to add u2 plus u3 plus u4 plus u5, essentially. Okay? If I wanted to make an infinite series, it's the same idea. So I'd put my summation sign. Let's say this time we're starting with the first term, and then I want to add it infinitely. Then I just put my infinity symbol above it, and then put in my equation. So this means I'd be finding the sum from u1, and I would keep adding these terms forever. Okay, which we can't physically do that forever, obviously, but we're going to learn in later videos about some sequences that you can actually figure out what the sum would be if you go to infinity. So let's go through a couple of examples. Pause the video and try them on your own, and then let's see how you do. So in this first one, we're calculating the sum of this series, and it says we're starting with the first term and we're stopping at the third term. So I'm first going to find each of those terms. So my first term is going to be negative 2 to the first times 1 squared, which would just be negative 2 times 1, or just negative 2. My second term, negative 2 squared times 2 squared, which would be 4 times 4, or 16. And then my third term, negative 2 cubed times 3 squared. So this would turn into negative 8 times 9, or negative 72. So to now calculate the sum, we're just going to add all of these together. So negative 2 plus 16 minus 72, and that equals negative 58. Okay. For our next two examples, we're going to write the series in sigma notation. So we're given this series here. We could write it without the plus signs as well, if that looks a little easier. 2, 4, 8, 16, 32. So just like we did with the sequences video, we want to figure out what's going on here. So I have 2, 4, 8. So this is particular numbers, which are powers of 2. So I could write the first number as 2 to the first, 2 to the second for the next number, 2 to the third, and so on. So the equation for this, or the expression I should say, would be whatever n is, it's going to be 2 to the power of whatever term. So that's my first part, and that's important. Now we want to look at how many terms are here. So we're going to start with my first term, and we're going up to my first, second, third, fourth, fifth term would be the last. So to put this in sigma notation, I'm going to write sigma. This is my equation, 2 to the n. My first term happens when n equals 1, and my last term happens when n equals 5. So that's how we would write this in sigma notation. So before we start this one, I'm actually going to make this one infinite. I'm going to make it go on forever, just so we have a different example. Okay, so in this one, I'm going to ignore the signs to start with. I see a 1, 4, 9, 16, 25. These all should stand out to you as perfect squares. So this is 1 squared, 2 squared, 3 squared, etc. Okay, so that part would just be whatever term it is, so n squared. Now let's figure out how we get these alternating signs, the pluses and minuses. So the way that happens is we use -1 to a power. We could either do -1 to the n or -1 to the n minus 1. So let me show you what happens. If I plug in, we're going to start with this top one. If I plug in 1, my first term, I would get -1. If I plug in 2, then I get -1 squared, which is +1. If I plug in 3, -1 cubed is -1 again. So do you see how this would keep changing the sign? Okay. If I use this one, this bottom one down here, when I plug in 1, I get -1 to the 0 power, which is actually +1. When I plug in 2, -1 to the first power is just -1. And then again, it's going to keep switching between them. So the reason I use both of these is we look at our starting value. If our starting value is negative, we would use this top one. If our starting value is positive, we would want to use this bottom one. So because our first value is positive, we're going to use -1 to the n minus 1. So this would be our equation. This part changes the sign, and then this part gives us our perfect squares. So now to put it in proper notation, I'm starting when n equals 1, and because I added these 3 little dots, we would be going out to infinity. So that would be your series. In this video, we learned the definition of a series, how to write a series using sigma notation, which has this Greek letter sigma, and how to evaluate a series written in sigma notation. Thanks for watching.